Okay, in this video, we're going to be looking at a method for solving quadratic equations of the form ax squared plus bx plus c. So we're working with a quadratic trinomial, and in this specific case, the a value is going to be greater than 1. There are quite a few methods for dealing with this kind of quadratic trinomial. I'm going to be demonstrating splitting the linear term. And in this case, that is the 10x. Very first step that you want to do when you're doing any factoring method is to get the equation in general form, which means to zero it out on one side. So in order to do that, we're going to subtract 3 from both sides. That'll create a 0 on the right-hand side, and then all three terms, 8x squared, 10x, and negative 3, will be on one side. So that's general form as your first step. Okay, then we're going to be doing steps 2 and 3 simultaneously. These will be the steps that you need to put the most thought into. They have to do with you understanding not only your times tables, but also understanding negatives and positives so that you get the negative on the proper number if there are any negatives, and the positives where they belong. So let's talk about that. Step 2 involves trying to find a product of two numbers that's equal to the a times the c value. So we do have to be very aware of what's a, b, and c. This is your a value. It's the coefficient of the squared term or the quadratic term, it can be called. Your b value is the coefficient of your linear term. And c is the negative 3, the constant. So I'm going to speak about these values as I discuss steps 2 and 3. In step 2, we're looking for a product that's equal to the a times the c value, which as you can see is 8 times negative 3, negative 24. But in step 3, we're going to want to make sure that the two numbers we came up with here to multiply to give us negative 24, that those numbers also add to give us the b term, which is 10. So the step where you're really thinking about this is because there are several possibilities here for the negative 24. To get 24, and right now, why don't we just think of how to get a 24, and then we can worry about who gets the negative and who gets the positive, because that's going to come into play when we consider both of these steps together. So different ways that we can get 24. We could go 1 times 24. That's a possible way to multiply two numbers. And we could, again, we're going to decide who gets the negative because one of them has to be negative in order for this to happen. But we're going to make a real solid choice on who gets the negative by also considering this simultaneously. We could also go 8 times 3. We could go 6 times 4, all ways to get 24. And we can also go 2 times 12. Okay, so now as we look at these two steps and realize that whatever pair we use, there's 4 different pairs here, and we're going to decide which one. Whatever pair we're using does have to add up to 10, but yet we also have to get a product of negative 24. So let's think about that and what it means to get a product of negative 24. If you're getting a product of negative 24, only one of these numbers can be negative. If one of them is negative and one of them is positive, then when you get to this step, you're really going to be thrown into a subtraction situation. Even though the formula says that you should be able to add the two numbers to get 10, one of those numbers being a negative is going to automatically force you into subtraction. So while the 6 times 4 looks really like it might be a tempting choice because you're looking at that and saying, oh, I can get 10. That means you're not really considering both of these situations, both of these requirements at the same time. And again, you need to think about these together. Make both of them work at the same time. So the 212 would be a better pair because one of them could be negative, and even after one of them becomes negative and you get into a subtraction situation, you're still going to get a 10. Whereas if you try to do that with the 6, 4, let one of them be negative. If the 6 is negative and you add these two numbers, you get a negative 2. If the 4 is negative and you add the two numbers as you have to in step 3, then you get a positive 2. So neither one of those would work. So while that is tempting, it's really the 212 pair. Okay, who gets the negative? Well, another thing about negatives is that when you're adding two numbers, the larger number overrules with respect to the sign. We want to be able to add and get a positive 10. So the bigger number should be positive to get a positive 10, and the smaller number should be negative. Hey, once you're confident and you have checked that this works out, we are getting a negative 24 because only one of our numbers is negative, and that when adding, you're also getting that b value, then you're ready to split the middle term, the linear term. So now let's come over here for step 4. We're going to keep the quadratic term as is, but the middle term, or what we call the linear term, is going to be rewritten, split up into two terms using these two numbers. So we're going to say negative 2, but with x's on it, and positive 12, but with an x on it. And these two terms together is us splitting up this 10x. Notice that when you combine those two, it is equal to the 10x. Bring the negative 3 down, bring the 0 down. Once you get to this step where you have split up the middle term, you've gotten into a situation where you've gone from 3 terms to 4 terms. So that means that the factoring, instead of the typical ways in which we factor a quadratic trinomial, we are now ready for factor by grouping because you now have 4 terms. And so factor by grouping is suitable. If you recall the method of factor by grouping, you're going to group 2 terms at a time, taking out the GCF each time. So if I group these 2 terms together, this will be step 5, where we're going to factor by grouping. Here we split the middle term. Okay, so factor by grouping, largest factor that goes into both of these is 2x. So we're going to take out that common term and put 1 parenthesis next to that GCF. Every time you take a GCF out of an expression, it is used as a multiplier to regain each of the terms that you took it out of. So 2x multiplied by what? Gives you 8x squared, 4x. And 2x times what gives you negative 2x minus 1. Okay, we're done with the front 2 terms, and we're going to go to the back 2 terms. Take out a GCF again, and the GCF here, largest number that goes into both of these. They don't both have an x, so that's not common, but the largest number at least that goes into both of these is 3. So we're going to take out a GCF of 3 for these back 2 terms, single parenthesis. You can bring down the equal sign and the 0. And again, use that GCF as a multiplier to regain both of these terms that it came from. So 3 times what is 12x? 4x. And 3 times what is negative 3? Negative 1. Notice at this point that you have a factor here that matches a factor in this term. We're going to look at this as 2 terms, the term before the plus sign, the term after the plus sign. And we're going to do the GCF one more time. Factor by grouping, you're taking out a GCF 3 times. We did it once here, we took out another one here, and we're about to take out a third one. So what's common to this term as well as this is 4x minus 1. And then what goes in the back parenthesis, again, you ask yourself, if this is my multiplier, what do I multiply this by to get back this term? And it would be 2x. And what do I multiply this by to get the back term again? And it would be 3. So just those terms that are out front is what completes the second parenthesis. Once you've broken this down into two linear factors, you are now going to go into using the zero factor property in order to actually finally get the solutions. The zero factor property, if you recall, we use it every time we factor, regardless of the method. And that property states that when two things are multiplied together, when they are factors and it results in a product of 0, then either this one can be 0 or this one, or potentially both. So that gives you the right to set each factor equal to 0 and to get solutions from both of these linear equations. If we solve this one, we'd have to add 1 to both sides. That would give us 4x equal to 1. And then divide by 4, and you would get x equal to 1/4. If we solve this one, we would subtract 3 from both sides. That would give you 2x equal to -3. Then divide by 2, and we would end up with x equal to -3/2. And those are finally the two solutions, -3/2 as well as 1/4. And that completes the demonstration, a method called splitting the linear term used for a quadratic trinomial when the leading coefficient is bigger than 1.